Hey everybody, this is Future Zach coming in to give you a little background on this video/series. Basically, I've been throwing around some ideas for a programming language for a while, been watching Jonathan Blow videos and stuff, getting inspired, thinking about things. Long story short, I decided to just say fuck it and make it a reality. So I'm going to be making a programming language and a compiler for it. I'm writing all of this in C because I figure I could use some more experience in something more low level. Plus, I'm going to be transpiling to C, plus it's a very portable language, so if I want to make this thing cross-platform, which I do, it won't be a hassle. Now, do I have any prior experience making languages or compilers or interpreters or anything like that? Not really. I haven't taken any classes about this stuff, I'm just interested in it, so I'm sure it will be a long and arduous struggle, but it'll be fun, and it'll just be a chill little series where I can hang out and code some stuff, and maybe you'll learn something. Also, I just want to note that this video is mostly post-commentary, but I might switch to a more live style in the future if I get more used to talking while coding. I did try it for this first part, but I just didn't really know what to say, and the commentary was very slow, so I decided that dubbing over it in post would be a better choice. So the first thing I do is set up a little idea file where I can just jot down concepts and design pillars for my language.
I know the language name. It's going to be called Juice, because I like juice. I like juice boxes.
It's going to be statically typed because I'm going for something that's easy to compile and efficient. I want to use a table system for my objects, similar to JavaScript or Lua. I'm going to try and keep things simple because I don't want to end up with a bloated or messy language, although we'll see how long I stick to my guns on that. I also want typing code to be fun and convenient, so I'm going to introduce some features like calling multiple methods from an object in one statement or allowing multiple return values. I've got some other cool ideas here as well, but we'll get into those at a later date. And my other design pillars are consistency, speed, and cross-platform compatibility. Those are all things that are very important to me when I design pretty much anything, and I'll probably make this open source at some point. Next, I just set up an example code file so I can have something to actually pass into my compiler. I figure that for now the most important things are variable declaration and assignment. Arithmetic operators will come next, and then maybe printing so I can debug more easily. Now, it's time to write C code. I start out simple, just checking how many arguments were passed into the program so that I can determine whether there's actually anything to compile. If there aren't any arguments, I'll just print the name and version of the language, pretty standard, and if there are arguments, I'll just compile the files whose names were passed in. I actually screwed this up because I forgot that the executable name counts as the first argument, so it was trying to read the compiler binary as if it were my source code. Anyway, I'm going to open the source code file in read mode and start lexing or tokenizing it. What this means is that I'm going to convert everything in the program into a list of tokens that the compiler will then convert into something more usable by a computer. Basically, for now, just think of a token as a representation of the smallest meaningful unit of a program. So, for instance, a keyword like for, while, int, float, etc., or an operator like plus or minus, or an identifier for a variable or constant. At this point, I deliberate for about 3 minutes about what the difference is between data on the stack and data on the heap, even though I've probably been taught it very explicitly like 9 times in school at this point. I end up deciding that putting my array of tokens on the stack local to the tokenized function is the right play. It was not.
Let's see. This can be a byte. Is byte a type in C? I actually don't know.
Next, I'm going to read the data in the source code file into a temporary buffer, character by character, and as soon as a delimiter, that being a character that separates tokens, is read, the buffer will be converted into the appropriate token and added to the array. Now, there are functions to read a full line or a set number of characters from a file in C, but I decided to do it one character at a time because those other methods require you to specify a maximum length, and I don't want to limit programmers by telling them, hey, in my language, you can only put 256 characters on a line. And also, because I just find this method, more intuitive. Anyway, I started writing this bit and then thought, you know what? I think I'll make this stupid. And fucked the whole thing up. Then decided the first way was better about 15 minutes later and changed it back. Classic. This is why I'm doing post-commentary. During this whole debacle, though, I did learn a few things. Number 1, I should be using sternkump instead of sturkump to check for tokens, since sternkump lets you specify the length to check. And because of the way I'm reading in the characters, that prevents me from also checking the character after the token, which would result in an inequality. Number 2, I should make sure to seek back one position in the file whenever I find the end of the token, since I always have to read one extra character past the token's end in order to determine that it is actually terminated. And number 3, writing everything in one file is a stupid fucking idea and I should be waterboarded for doing it. Now everything is in 3 files. So I went ahead and wrote the code to detect comments and discard those lines, and to detect spaces and convert the buffer into a token. To actually keep track of the tokens, I need an expandable array, so I basically just implemented a typical list data structure for this. It allocates memory for one token to start with, and then doubles its capacity every time it needs more room. Now, you may notice something. Do you see it? Do you see what's missing here? I may have forgotten to actually increase the list's capacity variable to 1 when the first object is added to the list. That caused this to just straight up not work, and I spent a long fucking time trying to figure out why. I thought that realloc was somehow clearing out the previous data. Well, it wasn't. Realloc doesn't work like that. The documentation says it doesn't work like that, and I just decided to believe in my own code over the literal C programming language. Yeah. The actual token struct is pretty simple. It just has an int representing the type of token, because there are no enums in C, and a string with the text representation of that token. The text representation isn't strictly necessary for all tokens, but we'll need it for identifiers, so I'm just going to set it for everything. It'll also make debugging way easier. So I wrote all this code, made a loop in main to print out my list of tokens, hit compile. It was mostly stupid shit. Got the compile errors fixed, and there it is. That's why putting my list on the stack was a bad idea. As I understand it, stack variables, aka local variables, are automatically freed from memory when they go out of scope. Now, I thought that if I passed the variable to another function or returned it, that it would stay in scope. And actually that might be true, I'm still not actually sure. But clearly I was not thinking about the fact that I was actually just returning an address to a local variable. Basically, the variable was going out of scope, so the address I was returning was pointing to freed memory, which is a no-no. So I malloced the list, still got a seg fault. Freed the list, still got a seg fault. Commented out the code that prints out the tokens, no seg fault. What the fuck? And now, a lesson on Makefiles. A makefile is a file that helps automate build tasks. In this case, I'm using it so that I don't have to type the whole compile command in the command line every time I want to rebuild my program. Something important about Makefiles is that they were designed with large projects in mind, so they have a nice feature that can determine whether to rebuild something based on whether or not a file was changed. The way this works is that you specify a target to build. This name should match the output file name. After the target, you specify prerequisites. Every time you type make and the name of the target, Make will check if the target, aka my project's executable, is older than any of the prerequisites, and if it is, it will run the commands you've written below the target. This is super cool because you can chain together multiple make commands so that you only rebuild the files you need to. But for my purposes, I'm just rebuilding everything every time, and this is fine because I don't have a big code base. But, and you may have seen where this is going, I do have to add a new prereq for every file, or else Make won't necessarily rebuild my project when I make changes. And what did I forget to do? This has been a lesson on Makefiles. After fixing all this, I was still getting 0 tokens in my list. This was because I was checking the wrong command line arguments as previously mentioned. Easy fix, just a couple of infinite loops later, we've got 7 comments? One issue was that I was just setting the first character of the buffer to the null character when I cleared it, but I wasn't clearing the characters after that. I also replaced my 2 straggling sturkump calls with sternkump, and that fixed it. Next on the agenda is to lex identifiers, those being variable names. This wasn't too hard, although I did run into some issues with some things that I mentioned previously. Not setting the list capacity. Lastly, I decided to use a different method for my lexing, because checking for a delimiter like a space and then reading the buffer for a token just isn't great. For instance, if we were to have a dot, as in object.SumMethod, that dot is not a space, so I would have to write in another case for that. Same with any other operators that aren't separated from their operands by spaces, or stuff like parentheses and brackets. So what I'm doing now is first checking for single character tokens, since those are easy to check. If there isn't a valid single character token, I read in the number of characters in the longest keyword, since that's the longest token we'll ever need to check, except for identifiers, and check that buffer to see if it matches any valid tokens. Since I'm using sternkomp, it doesn't matter if I read in additional tokens to the buffer, since I'm only checking the first however many characters. Then if a token is found, we add it to the list and seek backwards to the character directly after that token. Actually, I don't think I implemented that part that goes back yet. Fuck. Okay, glad I caught that. Well, that's it for this video. Tune in next time to watch me attempt to make a parser, which is going to convert our lex tokens into a tree of operations that actually, well, means something to a computer. Should be hard, should be fun. That was my nickname in high school. Good night, America.